Hi guys, today we will study electricity markets, and in this lecture we will just define some of the basic terms like utility function, cost function, and explain the demand and suppliers behavior and how to derive them, and also why electricity market is necessary. So let's see. Okay, so first is utility function. So basically it gives a dollar value of your happiness, or basically it's the value for the quantity that you are buying. And for example, how much in terms of electricity, so it's how much you are going to pay for that electricity. And so some of its properties are that a first derivative of the utility function must be greater than 0, and this we also call inverse demand curve, and also denoted as PD of Q. And secondly, u double derivative Q is less than 0, and basically this is a concave function. So now you will be seeing, if we do some explanation in the simple terms. So for example, you are thirsty and you need water, so in the start you will pay more price for the first cup of first cup or something like that, but for the second cup you won't pay that much, and the price you are not going to pay that much. For example, for first glass you paid $10, for the second you will pay just $1 or $5 something, because it didn't have that value. So you can learn in this in that way, that for u dash of q first derivative will be greater than 0 and second derivative will be less than 0. Okay, and similarly the P is the price of the product, for example electricity, and Q is the quantity of the product. So now coming to it, the demand consumer surplus. So now let's model the behavior. So as a consumer, what do you want? The and your so your end goal will be that you have the maximum money left with buying the best quantity, or the quantity that you require. And so this can be equated in the equation as utility function minus P of Q, and P of Q are the product price into quantity. So basically we want the maximum utility, and so if we take derivative with respect to Q, so it will be u dash of Q is equals to P, and we call this first derivative also as marginal utility. And so this is basically the optimal rate of consumption is where the marginal utility is equal to price. So we can see that this at this price we will have the optimum or the best quantity. So like for example, if I buy Q dash quantity, then I have maximum money in my pocket, and that's the optimality condition for consumer. So, and we can see this from the graph as well. So the first derivative of the utility function u of Q, or u dash of Q, is known as the inverse demand curve, and will be denoted as PD of Q. The inverse demand curve shows for each rate of consumption the corresponding price that a price taking consumer is prepared to pay to sustain that rate of consumption. And the inverse demand curve is downward sloping, as you are seeing, an increase in the market price corresponding to lower rate of consumption. So it's a general rule. Like for example, if the prices of electricity increase, of course you will then try to limit down your use, and you will like tend to use less electricity because you have to you don't want an extra bill. So for a price taking consumer facing a linear price, the consumer's demand function is given by this downward sloping, and we explained it. So this was the inverse demand curve. So we can also find its demand curve by taking the opposite, or in this case, like it was u dash of Q, we will integrate it and we will get the demand curve, and this will be basically the rate at which the customer is willing to pay. Okay, now coming towards the supply and producer surplus. So basically C of Q is the cost of product at the rate of the quantity is produced, and so we will consider C dash of Q is greater than 0, and C double dash of Q is also greater than 0, and the first derivative of C this is also called the marginal cost. So you can consider these as, for example, you are a generation department, or you produce electricity, and you are producing for example x amount of quantity, but during that production you are told to produce more. So of course it will take more cost, so that's why the first derivative is greater than 0. Then you will say why the first double derivative is greater than 0. So this will be because for example, if you completed your production for that given time, then you are told to say that again we want more electricity from you. Of course it will be more cost, so that's why you can remember these terms in that way. And basically the cost function is a convex function. Okay, so now what does the producer want or the supplier want? He want to maximize his profit, so we can write the profit function in this form. So basically it will be revenue minus costs, and here you can see that as the cost function is convex, but due to the negative sign here it will make this a concave function. And when we take the derivative, so we get the price is equal to marginal cost function. So it can also be explained in the same way that for a given quantity there will marginal cost and like that. Okay, and similarly we can also take the inverse or change the cost function into integration form, and you can say that this orange shaded area is basically the cost function, and the PSQ is also called, this is also called the supply curve. Okay, now if we want to maximize the short run efficiency, so what will that be? So basically what we will doing is that we will be maximizing the utility or the dollar value of happiness minus the cost. And so what constraints will there be? So first constraint will be that the buying quantity must be equal to selling quantity, and also the alpha and beta also show some of the constraint on the supplier and the buyer side. So we will use the KKT conditions, and so in KKT condition first we get the objective function. As we can see, this is the objective function, and then as this is maximization we will add the rest of the constraints like this, plus lambda plus summation alpha I and plus lambda b. Now you will be wondering why this minus gi of x. So basically what happened is that we are so this is an inequality sign but with less, so we change it to greater than sign, and for that we have to take negative and the sign will change. So then there is dual feasibility constraint, and so lambda is basically will be the value. So if it's equality sign, as in this case, because we will shift this and this will be equal to 0, so that value will be itself, but the inequality will be a non-negative value, as you can see here. Now we will take the derivative with respect to L, and we get these values now, and we will equate them also to 0. And keep in mind we took the derivative with respect to the quantity of the buyers and quantity of the supplier or the producer. Now and then in the last step we do the complementary slackness condition. So basically we equate the constraint to 0, and through that we get the value of alpha and beta, and from here we got 0. And we will, when we put this in 1 and 2, so we say that the utility will be equal to the marginal utility will be marginal cost at lambda. So when we look at the so marginal utility equal to the cost, and so now when we, so this is the orange line is basically marginal cost, and the purple line is the marginal utility, and the point they intersect is the basically the buying quantity must be equal to selling quantity. And if we look at this area will give us the economic welfare. So can this be achieved in the market? So as shown above, we solved these equations with the given constraint, and so this is basically the seller side, we have to maximize the profit, and here from the buyer side we have to maximize the utility. So using KKT conditions, we uh, found these values and equated to 0. So basically, in short run, welfare maximization can be achieved with a decentralized market if the market price is equal to the constraint marginal value of supply demand balance constraint in the welfare maximization problem. And secondly, all seller and buyer are the price takers. So of course they, like, as producer cannot set the price on himself, and then the decentralized profit maximization decision of all seller and buyer will be achieved through welfare maximization constraints. So there should, like, the both of them, like buyer and seller, cannot set the prices. And so we can see that the p is equals to lambda. So if, like, when the p is equals to lambda, so the market solution will be equal to a regulatory solution. As for example, there are regulatory bodies in a country if they don't have an electricity market. So but if we do the optimization for them and find the price is equals to lambda, then the market will be better than regulatory body. And this will be because the government will not have to take care of a separate department, because it will involve a lot of infrastructure cost, but rather a private firm or a secondary firm that will do the optimization and take care of this thing. And that's where it will be beneficial for the country, because they will be saved from a lot of cost. And that's why we prefer market, because it is a fair place, and the government is less burdened, and at that point we achieve maximum economic welfare. So this was for today, and in the coming lecture we will study the smart market. So see you.